Okay, I'm adding another short video to the 3132 review because I didn't have a problem with graphing a polynomial. So I'm going to do a video on graphing a polynomial using some of the concepts. And we're going to start with the following. Okay, our problem here is given f of x is the polynomial x cubed minus 2x squared minus x plus 2 and x equal 2 is a 0. Divide f of x by x minus 2 and find the other zeros. Now in the previous problems from the earlier review video, we found that if we could divide by x minus c and we got 0 remainder, then that meant x minus c was a factor and x equals c is a 0. Well, here we're given that x equal 2 is a 0. That means x minus 2 will be a factor. And by doing the division, we can rewrite f of x as x minus 2 times whatever that quadratic division result is. And then we can find the other zeros with that. So that's what we do. We do the synthetic division and then rewrite f of x in factored form and identify all the zeros. So we do the synthetic division, listing the coefficients 1, negative 2, negative 1, positive 2, and then since we're dividing by x minus 2, the 2 goes off to the left. Carry down the 1. 1 times 2 is 2. 2 plus negative 2 is 0. 0 times 2 is 0 for the next column. Add negative 1 and 0 makes negative 1. Negative 1 times 2 makes negative 2, and we get 0 for our remainder, which we better get. If x equal 2 is a 0, we better get 0 for a remainder. So that gives us a division result of 1x squared plus 0x minus 1. In other words, f of x equals x minus 2 times x squared minus 1. Now, we can find the zeros, the other zeros, by letting each factor equal 0. We already know that x equal 2 is a 0. That's what we'd get if we let x minus 2 equal 0. To find the other two zeros, we let that quadratic factor x squared minus 1 equals 0. Now, even if this didn't factor, we could find the zeros with the quadratic formula. But x squared minus 1, we can solve it either by extracting square roots or factoring it. Extracting square roots, x squared equals 1. So x equals 1 and also x equals negative 1. So our zeros here are x equal 2, x equal 1, and x equal negative 1. Now, zeros are defined as the x values when f of x is equal to 0. Well, f of x is just another name for y. So zeros not only have the property that when you have a 0, then x minus that value is a factor, they also have the property that if they're real numbers, they give you the x-intercepts, because y equals 0 for each of those values. So we have 2, 0, 1, 0, and negative 1, 0 are the x-intercepts. The zeros are not the intercepts. The zeros are just those values 2, 1, and negative 1. But we get the x-intercepts from those zeros. So we plot those 3 x-intercepts and then find more points to finish this graph. And to do the graph, you can either use the unfactored form to find points, or you can use the factored form x minus 2, and x squared minus 1 factors as x plus 1 times x minus 1. And plug your x values into that, or you could even use the form f of x equals x minus 2 times x squared minus 1, the partially factored form. Any one of those three forms can be used to evaluate more points for the graph. So that's the next thing to do. Plot those intercepts and find more points and finish this graph. I'll pause the tape and we'll come back and do that. So if you're not sure how to proceed, draw your graph and start with those intercepts. We know that we have the points 2, 0, 1, 0, and negative 1, 0. So plot those. Also, a nice easy point to plot, if we just let x equal 0, we get the y-intercept, which is 0, 0, 0, plus 2. So there's another nice easy point for the graph. So we actually have one of the points in between two of the x-intercepts. Now you want to find a point in between 1 and 2. I would suggest 1.5. You'll want to use a calculator. 1 point to the right of 2, maybe at x equals 3. And then we'd need one more point to the left of negative 1. Negative 2 looks like a good one. So find those 3 values, and you should be able to complete the graph. So when we plug in those values, 1.5, we could either use the top form or the factored form. I did it both ways. I got negative 0.625, which actually corresponds to some fraction, but you don't want to do all those fractions. Just get out the calculator and calculate it out. So 1.5, it dips below the x-axis a little more than a half below the x-axis. 3, when we plug it into the factored form, we get 1 times 4 times 2 is 8. So 3 gives us the point, or the y value, up at 8. And negative 2, when we plug it into any of the forms, we get negative 12, which is like way off my graph. And I'm not going to plot it because it's like halfway to the floor. But it tells me what the graph does. It tells me that the graph's going way down to negative 12. In fact, it's probably going a little steeper than what I have there, probably more like that. That's a pretty close graph. Some students ask, well, how do I know how high this graph goes or how low this graph goes? How do we find the equivalent of the vertex, from parabolas? And the answer to that is we have to use calculus to identify the exact value that this graph maxes out or bottoms out. This point right here, somewhere very close to here is a point where it maxes out, and somewhere close to 1.5 it bottoms out. But we can't do it with what we know from this class. We can approximate it with a graphing program, just zoom in, but we can't find the exact value. So that's the graph. That's the concept. Zeros give you the x-intercepts. So we'll see you next time.